Python versus R, which one should you use? Hey everyone, welcome back to the channel. Today we're tackling one of the biggest debates in the data science world, Python versus R. So if you're wondering which language is best for you, or if you're trying to decide where to start, I've got you covered. By the end of this video, you'll know the strengths and weaknesses of each language, and hopefully you'll have a clearer idea of which one suits your needs. When I was starting out in data science, I remember feeling a bit overwhelmed with all the choices. You hear people say, learn Python, it's the best. And then others swear by R because it's so powerful for stats. So today, we'll go through each area where these languages shine and how they compare. I'm going to walk you through the basics, but we'll also dive into specifics like usability, the power of their libraries, visualization capabilities, performance, and even the career impacts of learning one over the other. And hey, stick around until the end. I'll share my personal recommendation and a couple of pro tips on learning each. All right, so first up, what is Python? Python is a general-purpose language, which basically means it wasn't built just for data science. Python was designed to be simple and readable, so you could use it to build anything from web apps to machine learning models and even software automation. Over the years, Python has become super popular because it's easy to learn and very versatile. Think of it like the Swiss Army knife of programming languages. On the other hand, R is a bit different. R was designed by statisticians specifically for data analysis. It's not trying to be an all-purpose language. Instead, it's hyper-focused on data analysis and statistics. So if Python is the Swiss Army knife, then R is like a laser-focused tool for data work, maybe more like a scalpel. So the big question, should you go for the all-purpose tool or the specialized one? To answer that, let's break down some key differences. Now, let's talk about ease of learning, which is a huge factor, right? Python is famously beginner-friendly. Its syntax is almost like English, so if you want to write a loop or a function, it's usually pretty readable. That's why people say Python is a great first language. You don't get bogged down with a lot of syntax complexity. For example, if you want to print out numbers from 1 to 5, you can just write for I in range 1 to 6, print I. Even if you've never coded before, you can kind of guess what it's doing. That readability is a big advantage, especially when you're first getting into data science and you don't want to be distracted by confusing syntax. Now, R isn't quite as straightforward, especially for those who are new to programming. R has its own unique syntax, which can be a bit harder to read at first. If you're familiar with statistical methods, though, you might find R to be pretty intuitive once you get past the syntax. For instance, if you're writing a basic function in R, it's written a bit differently. For I in range 1 to 5, print I. You have to know specific symbols like the colon and curly braces, which can feel foreign at first. So, in terms of learning curve, Python might be easier for most people. But if you're into statistics or coming from a research background, R could feel right at home. Either way, both are doable if you're committed. One of the things that makes Python a powerhouse for data science is its extensive library ecosystem. You've got pandas and NumPy for data manipulation, which are essential. Then there's scikit-learn for machine learning, and TensorFlow and PyTorch if you're diving into deep learning. Basically, Python has a library for everything you could want to do with data. On the flip side, R has its own powerful packages too. Packages like dplyr and ggplot2 are amazing for data manipulation and visualization, and there's caret for machine learning. And what's cool about R is that it's built with a strong statistical foundation, so a lot of its packages are very stats-oriented. For example, if you're cleaning a dataset and need to filter, sort, or group data, both pandas in Python and dplyr in R can do the job. But if you're going into advanced statistical analysis, R's packages might give you more built-in functionality. If you're leaning toward machine learning and deep learning, Python's ecosystem is more mature. But if your work revolves around data cleaning, wrangling, and statistical analysis, R's packages might suit you better. Both languages have robust support, so you're covered either way. All right, now for visualization, which is one of my favorite parts of data science. In Python, you've got matplotlib, seaborn, and plotly. Matplotlib is kind of the OG library for plotting in Python. It's super customizable. Seaborn builds on Matplotlib and makes it easier to create beautiful charts quickly. Now R has ggplot too, and honestly, it's like the gold standard of data visualization. It's incredibly powerful and elegant for creating complex visualizations. With ggplot2, you can make almost any kind of graph with just a few lines of code, and it's particularly amazing for statistical plots. So, if you're just looking to get some graphs up, Python's libraries might be easier to jump into. But if you're serious about visualization, R's ggplot2 has a lot of high-quality tools to make your visuals really stand out. In a nutshell, R is the go-to for data visualization, especially if you're working in analytics or research. But Python's libraries have come a long way, and Plotly, in particular, allows for interactive plots, which is a big plus if you're working on dashboards or presentations. Now, if your work involves a lot of statistical analysis, R is really hard to beat. R was created by statisticians for statisticians, so it has tons of built-in support for stats functions, models, and tests. Python also has libraries for stats like SciPy and stats models, and they're definitely useful, but it's not as specialized as R. You may find yourself adding more custom code in Python to achieve the same statistical depth that R offers out of the box. Say you're running a t-test or a chi-square test. In R, you could do it with just 1 or 2 lines of code, and you get a well-formatted output. In Python, it's doable, but can be more cumbersome, especially if you need a lot of advanced statistical options. When it comes to machine learning, Python is kind of the king. You've got scikit-learn, which is a phenomenal library for ML. Plus, if you're into neural networks, TensorFlow and PyTorch are industry-standard libraries, both based in Python. R does have machine learning packages like Caret and MLR, which are pretty good, but they don't have quite the same support and flexibility as Python's offerings. R is more suited to smaller, straightforward models, while Python's libraries make it easy to scale up and experiment with complex algorithms. If your goal is a career in machine learning or AI, Python is hands down the better choice. But if you're just doing some basic modeling for analysis, R can still get the job done. Python is one of the most in-demand skills in tech right now, across data science, web development, automation, and more. If you're looking for versatility, Python is definitely more broadly applicable. R is popular in academia, bioinformatics, and research-heavy fields. If you're going into a research role or a field that values statistics, you'll probably see more R. So for most people, Python might open more doors, but if you're in a highly specialized field, R could be an asset. So let's wrap it up. Python versus R. Which one should you use? Well, Python is versatile, beginner-friendly, and ideal for a wide range of applications, from machine learning to automation. R is perfect for stats-heavy roles, advanced data visualization, and niche areas like academia and research. If you're starting in data science and want broad career options, Python is probably the way to go. But if you're in a specialized area or enjoy working with stats and visualizations, R is incredibly powerful. Thanks for hanging out with me today. Let me know in the comments which language you're leaning towards, or if you use both. Don't forget to like, subscribe, and hit the bell for more data science content. Until next time, happy coding.